last and final unit this year is a statistics unit. We haven't really done any statistics yet this year, so we're kind of taking a big 180 from what we've been doing, which I think a lot of you guys are actually going to like. So before we get started with all the different kinds of graphs and ways we can display data, we first have to talk about the types of data we're going to work with. So there are two types of data we're going to work with, and the first one is quantitative data. So do you see how this word quantitative has the word quantity in it? Well, a quantity is an amount of something. So quantitative data is data that expresses a certain amount. And usually these have units. Okay, or in other words, they can be counted. Okay, so one other way to think about this is that quantitative data defines. It gives a specific number or value to something. Okay, and we see that a lot when we take a tally. How many? What's your height? What do you weigh? Those are number answers that you give. Okay. Qualitative data, on the other hand, it's data that measures attributes. Like they were all wearing blue. They measure properties. Was it big? Was it small? Was it average? Or characteristics. And we call that this qualitative data describes. You'll also notice the word quality is in there, right? Like people have all kinds of qualities that aren't necessarily values. They're like adjectives. So qualitative data is like adjectives descriptions, and quantitative data is like numerical descriptions. Okay. So this learning target, we're going to use a lot of quantitative data, and we're going to talk about dot plots. That's the first kind of graph we're going to work with. Now, these should not take you very long. The first couple learning targets here, this should all be review. I just want to kind of get into the feel of what these graphs look like. So a dot plot, it's a graph used for small data sets. And also the values fall into really specific categories. So let's take a look at this first example. A farm studying the weight of baby chickens after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot on the axis given. So here's the data. It's all these numbers right here, and it's in a long row. Okay, so there's all the data. You'll notice the numbers aren't in a certain order. Normally when you take a survey or ask a bunch of questions, you don't get it numerical order, right? Someone might say 2, the next person might say 3, but then the next person might say 1. So order is not always there when we get a data set. Okay. You'll also notice we have a number line here from 0 to 8, and we have a description at the bottom of what we're actually looking at. So 0 through 8 is actually the weights, right? 1 ounce, 2 ounce, 3 ounces, etc. So to make a dot plot, what you're going to do is you're going to take each number. So the first number here is 2, so I'm going to make a little X or a dot at 2. I make X's, I prefer X's, but you can also make it like this. Right? You're going to see it both ways in the learning target. So dots or X's, doesn't matter. I'll do dots right here. So, and then I cross off the number to make sure I know I've plotted it. So the next one is 1, so I'm going to plot a 1. Then 3, plot a 3, 4, plot a 4, 2, 2, 2, 2. So you can kind of see how I'm going here. So what I'm going to do is go ahead and pause and finish filling out this dot plot. Now, you should get a dot plot that looks like this. You got 2, 3, 5, 4, 3, 2, and then 1 on the 8. Okay. Now, a couple things with the dot plot. You want to make sure that when you look at these, they all kind of line up. So I know 3 has 5 because it's 1 more than 4 here, which is 1 more than 3, which is 1 more than 2. Like, I can actually get a really good idea right away when I look at it. The second that's nice thing about a dot plot is that I've taken all my values and I've put it on here so I can easily see which values stand out. And I can kind of see which values don't stand out. Okay, so when I look at this, and I always want to make an observation with my data, one of my observations that I see is that I think that most chicks, most baby chicks, fall into this range or this number, right? 3 or 4. So my observation is that most chicks weigh around 3 or 4 ounces. There are other observations you can make here. You can say that there's one chick that weighs 8 ounces, which is really not at all close to what the others weigh, okay? We kind of call that an outlier. We're going to talk about that a little later, okay? So you want your dot plot to show clear data. What you want to avoid, and I'm going to do a little sample over here, is let's say I have some values, 3, 4, 5, and I make a dot plot. I do not want to do this. Well, I have 1 here, then 2, and they're not really lining up. Well, do you see how those don't line up? They have to be symmetric. Not symmetric, but they have to be in a row. So if I have 2 here, then a 2 should be here. If I have 3 here, then a 3 should be here, etc. To make those in lines, okay? So what makes stats a lot harder than other learning targets is that graphing in general, you want to be able to create a reasonable scale. So an extremely critical skill is creating that reasonable scale. And I say critical because it is really critical. The problems won't always provide you with one. Like this last example, we were given this thing. This scale right here, this 0 to 8 that was all spaced out really nicely, that was given to us. But in the future, we're not always going to have that scale. So in this learning target, we're kind of going to work on, how do we make a scale good? So this next problem, exercise 2, 12 employees at a small company make the following salaries. Okay, and they give you a list of all of these salaries from 25 to 60. And we need to decide which number line will work best. So I've given 3 options here. So here are the 3 options for number lines. Now, when I think about a number line, I look at the lowest value of the data. So there's 25 is my lowest, and 60 is my highest. So I have to have a scale that goes from 25 to 60. The other thing I need to notice in this data set is I need to know what the numbers are kind of going up by or down by. And so when I look at this, I'm saying, okay, this is going by 5s or 10s, right? Every number is a multiple of 5 or 10. So that's going to help me decide what I want to do. Oh, I didn't mean to make that line here. So let's look at the first number line here. This one goes 0 to 100, and I need to figure out, okay, well, what are those little in-between things worth? Well, this is 0 to 50, so I can see there's 4 lines in between, so this is going to go like this. Alright, that doesn't seem so bad, right? It's going by 10s or 5s. So now I'm going to take my lowest number, and it's 25, which means it's going to kind of fall here, right in the middle, which is kind of awkward, right, to have that 25 there in the middle, but that's not a big deal. The other number is 60, and that's going to go right here. Well, here's an issue that I'm seeing, and I hope you see it too, is that there's all this empty space. You don't want to have empty space on your number line. You want it kind of to fill the whole thing, right? If I go back to my other example here, this pretty much filled the whole thing except for 0, and 0 is impossible because a chicken can't weigh 0 pounds. So that's the kind of scale we want. So when I'm looking at this first scale, all my data is going to be between here and here. That's it. I'm wasting all that space. So this is not an ideal one, okay? Although it might be the best one of these 3, but let's keep going. All right, so now we've got another one, 20, 30, 40, 50, 60, 70. So I've got my 10s. That's really nice. And what's even nicer about this is these middle parts are the 5s. So 25, 35, 45, etc., right? You know those are 5s. So my lowest number is going to be at 25, which is right here, and the highest number in my set is at 60. Well, this isn't bad at all. I'm not going to have any in-between dots. It takes up most of the space. I have a little bit left over, but that's not such a huge deal. So overall, this one's not bad. Okay, I think this one's pretty good. Let's take a look at the third one. The third one is kind of strange. I'm not quite sure by looking at this exactly what number's in between 25 and 30. So 25 and 35, I have to actually figure out the middle part. And by the time I figured that out with using my calculator, I know that it's going to be 27.5. But that's a super awkward number to have in the middle of something, right? This is going to be 42.5. These are awkward numbers to be right in the middle here. Like, that's very strange. So that first of all is my question with this one. The second question I'm going to have is, okay, if we're going to start at, 25, which is like right here-ish. It goes up to 60, which is right here-ish. I have empty space and my scale is strange. So this one's definitely not good, okay? But it's important to know why they're not good. They're not good because the spacing is odd and you have a lot of empty space. So when you're making your scales, you need to think about that. You need to think a scale that represents the range of values, meaning your low to your high, and think about spacing. You also want it to be easy to read and estimate, right? That 27.5 is really awkward. And this is going to come up in this entire unit, is this idea of creating scales on your own. Okay, so we're going to have to practice that a lot in this learning target. Okay, so more importantly than your dots and making the dots in the right places, I'm going to care a lot about how you create your scales. Okay, so the other thing that we're going to work on, and this is pretty simple vocabulary, of the kind of distribution that a data set can have. So they can have 3 different types of distributions. They can be distributed and skewed to the left. They can be symmetric, and that's where it's like kind of skew. It's symmetric means that most of the data points lie in the middle, and it's pretty much even on both sides. Okay. Skewed to the left, even though it's called to the left, skewed means that you've got like some weird guys over here on the left. Like they're just kind of screwing up your data set because it's just 1 or 2 little guys onto the left. Skewed to the right is just the same thing, but you've got a few weird data points that are to the right. So it's kind of skewing your data. Like normally you've got this nice little set over here, but then the 2 of these guys is pushing all of those over. Okay? So be careful there. What's skewed to the left and skewed to the right is actually the opposite of what you think. So let's put both these ideas together, the idea of creating a scale and the idea of skewing. So here's a new set of data, and it is showing the number of miles run by members of 2 track teams. So members of Team A ran between 3 and 6 miles. Members of Team B also ran between 3 and 6 miles. So when I look at this data set, the thing that I'm measuring is their miles. So when I see my blank scales here, I know that both labels is going to be miles. So I'm going to have miles here. I'm going to have miles here. Now, to do the numbering, I know that my smallest number is 3 and my biggest number is 6. So I'm going to try first of all by going 3, 4, 5, and 6. Well, that doesn't work because look at all this empty space that I have. Alright, so let's try again. How about we do 3, let's skip 1, do 4, 5, and 6. This isn't bad, but it bothers me that I have these 2 empty bars. So instead what I'm going to do is I'm now going to start here at 3, 4, 5, and 6. Now look how pretty and nice and even that is. Now, if you had done the other way with the 2 little empty bars at the end, it wouldn't have been a big deal, but you want to try and even out your spacing as much as possible. Team B is going to have the same spacing. Okay, so I've labeled my scale and I've labeled my number line. So now I'm going to go ahead and plot my points. So I'm going to do Team A first. So this is saying that 2 members of Team A ran 3 miles. So that means I'm going to put 2 little X's or dots above 3. Done. Now 3 of them did 3.5. Now 3.5 is right in the middle here of 3 and 4, so I'm going to put 3 X's or dots there. 4 members ran 4 miles. So 1, 2, 3, 4. 4 members ran 4.5 miles. 1, 2, 3, and 4. 3 members ran 5 miles. 1, 2, 3. And 2 members ran 5.5. And no members ran 6. So I don't need to put an X for that. Okay. So now the next Team B we're going to plot. So 1 member in Team B ran 3, so 1 X on 3. 2 members ran 3.5. 2 members ran 4. 3 members ran 3.5. 3 members ran 5. 1, 2, 3. 4 members ran 5.5. And 3 members ran 6. So there are my 2 dot plots for both these track teams. And now I'm going to try and come up with an observation, and I'm going to use this right here that I just learned, this skewing, to kind of help describe my graphs. So when I look at Team A, I notice that Team A is symmetric. Most of the data falls in, most of the numbers around the middle go down, so it kind of looks like this. You have a height and then it goes down. Okay, that's symmetric. Team B, however, has a couple guys over here, like this guy right here, that's skewing the data. Because I've got the arrow going down here, but then on the left, it's kind of going up and down. It's not quite symmetric, so we're going to call this skewed to the left. Okay? But a conclusion I can make, even after describing this, is an observation I could be making, is that Team B, if I look at these data points right here, notice that Team B, you've got more people running these higher miles, these bigger miles. So Team B members are running further. Okay, and we always want to be able to make an observation from data. You know, the only point of collecting data is to attempt to make observations about it and think about what it might mean. Okay. The last question I have here is being able to look at a dot plot and make answer some questions about what you're seeing. So instead of just making your own observation, getting a prompt to answer what this is asking you to do. So this is a dot plot that is ages of workers at a food factory. So question A says, how many of the workers are 18 years old? So I'm going to go to 18. So this is 16, 17. So this is 18 right here. And I've got 1, 2, 3. I've got 4 workers that are 18 years old. B asks, what's the range of the ages of workers? Now I know when you look at this, you want to say 15 to 45, because that's the lowest number on the scale and the highest number on the scale. But there aren't actually any workers that are ages 15 or 45. So the range is actually, okay, what is my lowest to highest value? Not the lowest and highest number on your scale. So lowest to highest number is actually this 16 right here and this 42. So the range is 16 to 42, right? The youngest worker is 16, the oldest worker is 42. That is my range, so be really careful with that question. Would you consider this distribution symmetric? It very clearly should be no, because you've got these little guys out here that are skewing your data to the right. So it is skewed to the right. Okay? And then the last question says, the mean or average age for a worker is 22 years old. Why is this average not representative of a typical worker? So when I go look at 22 years old, so here is 22. I only have one guy that is 22 years old. And the reason we're getting an average age of 22 is because to find an average, you add up all these dots and divide by how many there are. And when you do that, you're going to get 22. However, most of the people are actually in this little area right here, and that's from ages about 17 to 21. So typical workers are actually between 17 and 21. The 22 is not accurate because of these little guys that I've circled in red. Those big numbers are skewing the data. So they're taking the average and they're making it seem higher than it actually is. Okay? So that's a lot of times in statistics, we look at data and we make these conclusions, but we're not looking carefully enough to ask ourselves why we're getting that value. And what does that mean in terms of the data, right? If I added those all up, I would get 22, but actually only one guy is 22. That's a really important thing to think about going ahead in this unit. Okay? So that's dot plots. This shouldn't take you too long to do to get us started here in this unit.